analyst helps translate business requirements into IT or information technology projects. System analyst helps in A system analyst helps in translating business requirements into IT projects by using techniques such as sampling, um, model building, and structured analysis, along with accounting principles to ensure the solution is efficient, cost effective, and financially feasible. And the system analyst also oversees the implementations, and this is to validate the performance of the system. Um, Next, we now move on to the traditional system development life cycle. Now, in the traditional system development life cycle, there are actually uh, five, five phases or five stages. The first is the planning, project planning phase. The second stage or second phase is the analysis phase. The third is the design phase. The fourth is the implementation phase. And the fifth is the support phase. First is the project planning phase. Here in this phase, the team initiate, they also ensure the feasibility, and they plan the schedule, and they also obtain the approval for the project. Now, if the project has been approved, then they move on to the second phase, which is the analysis phase. In the analysis phase, the team understands the business needs and the processing requirements. So this is where they prepare all the things that they need for the project. And then third is the design phase. Here, the team defines the solution system based on the requirements that they need and the decisions that they made from the analysis phase. And then, if they're finished with the solution system in the design phase, they move on to the fourth phase, which is the implementation phase. In the implementation phase, the team constructs, they also test, they also train the users, and this is the phase wherein they also install new system or systems. And the last one is the support phase. In this phase, they say that this is the phase when the team will keep the system running, and in this phase, the team will also do their best to improve the system. But that's it. And then, so let's have some more details about the planning phase. This phase is the fundamental process of understanding why an information system should be built. The planning phase will also determine how the project team will go about building the information system. Um, in order for the project to be successful, of course, they have to plan ahead of time, and they should plan as a team. And then there are actually two steps of the planning phase. First is the project initiation, and the second is the project management. When the team takes note of the system's business value. So they identify the business value of the system to the organization. How will it lower the costs or increase the revenues? So this is what they're going to take note of in the project initiation. And then the second step is project management. During this step, um, the project manager or managers will create a work plan and staffs the project, and they will put techniques in place to help the project team control and direct the project through the entire systems development life cycle or SDLC. Uh, Next is the analysis phase. Remember, this is the second stage or the second phase. During this phase, the project the project team investigates any current system, and they also identify the opportunities so that they can improve the project and make it better. And this is also the time when they develop a concept for the new system. So they answer the questions of who will use the system, what the system will do, and where and when it will be used. And there are also three steps of the analysis phase. First is the analysis strategy. Second step is the requirements gathering. And the third step is the system proposal. The first is the analysis strategy. This is developed to guide the project team's efforts. This includes the analysis of the current system. Second step is the requirements gathering. Um, the analysis of this information or pieces of information leads to the development of a concept for a new system. This concept is used to build a set of analysis models. And then the third step is system proposal. From the word propose, the proposal is presented to the project sponsor and other individuals who will decide whether the project should continue to move forward or not. So it's either it will be accepted or it will be rejected in the third step, system proposal. Mm, we move on to the third phase, which is the design phase. In this phase, it is decided how the system will operate in terms of the hardware, software, and network infrastructure, the user interface, forms, and reports that will be used, and the specific programs, databases, and files that will be needed. Um, here, this clarifies whether the system will be developed by the company or outside the company. Um, Actually, it has four components. The first is the design strategy. The second is the architecture design, and then the third is the database and file specifications, and the fourth is the program design. So um, the design strategy is thinking whether they will use the company, will be developed by the company or outside the company, and then the second is the architecture design, which is um, describing the hardware, the software, and the network infrastructure that will be used. That is the architecture design. The third is the database and file specifications. These documents define what and where the data will be stored. And the fourth is the program design. This defines what programs used to be written and what the team will do. Next, implementation phase. This phase is usually the longest and the most expensive part of the process because during this phase, the system is either developed or purchased in the case of packaged software. And then we also have three steps in this phase. The first is system construction, second is installation, and third is support plan. What do we mean by system construction? System construction is when the system is built and tested to make it perform as designed. Second is installation. Installation is the preparation to support the installed system. And the third is support plan. When we say support plan, this includes a post implementation review or can be a backup plan. Next, support phase. Support phase is the last phase. During this phase, the system is being run and improved. So those are the five steps now, or five phases, sorry. Now, what is a system development methodology? When we say system development methodology, it is a formalized approach or a series of steps to implement the SDLC or the Systems Development Life Cycle. So there are three system development methodology categories. First is the process-centered design or the PCD. Number two is the data-centered design or DCD. And number three is the object-oriented design or OOD. First is the process-centered design or the PCD. When we say process-centered design, it is a design methodology which proposes a business-centric approach for designing user interfaces or UI. But if we say data-centered design or DCD, the data is actually centralized and accessed frequently by other components which modify data. And the third is the OOD or the object oriented design, which is the process of planning a system of interacting objects for the purpose of solving a software problem. Now, aside from these, we also have the eight system development methodologies. Number one, we have structured design. Number two, the waterfall development. Number three is the parallel development. Number four is the rapid application development. Number five is the phased development. Number six is prototyping. Number seven is the agile development. And number eight is extreme programming or XP. So let us get to know each of these methodologies. First is the structured design. Structured design methodologies adopt a formal step by step approach to the SDLC or the Systems Development Life Cycle that moves logically from one phase to the next. This means that the design methodology introduces the use of formal modeling or diagramming techniques, which is to describe the business processes or process models and data models. So that's structured design. The second type is the waterfall development. With waterfall development based methodologies, the analysts and users proceed sequentially from one phase to the next. There are actually two key advantages of the waterfall development. First is that the system requirements are identified long before the programming begins. And the second advantage is that the changes to the requirements are minimized as the project proceeds. If we have the advantages of waterfall development, we also have its two disadvantages. First, the design must be completely specified before the programming begins. And then the second is that a long time elapses between the completion of the system proposal in the analysis phase and the delivery of the system. The third is the parallel development. This methodology attempts to address the long time interval between the analysis phase and the delivery of the system. There are actually two additional works when we use this parallel development methodology. Number one is the project division, and then number two is the integration at the end of it. Next is the rapid application development or the RAD or RAD. RAD based methodologies adjust the SDLC phases to get some part of system developed quickly and into the hands of the users. Most RAD based methodologies adjust the SDLC phases to get some part of the system developed quickly and in the hands of the users, since it's from the word rapid, so quick. So that's one of the main features of this methodology. The next one is the phase development. This methodology breaks the overall system into a series of versions that are developed sequentially. Here, the system categorizes the requirements into a series of versions. Then the most important and fundamental requirements are joined together or bundled into the first version of the system. The next one is the prototyping. Prototyping based methodologies perform the analysis, design, and implementation phases concurrently. So when we say concurrently, they operate they operate at the same time, or they occur at the same time. Here, all the three phases are performed repeatedly in a cycle until the system is completed. Um, from the word prototyping, a prototype is a smaller version of the system with a minimal amount of features. But there are actually two disadvantages of prototyping. First, um, it manages user expectations, and number two, um, there's a tendency to forget some important points since we are prototyping. So prototyping is the exact opposite of careful design. And the next is the agile development. This category focuses on streamlining the SDLC by eliminating much of the modeling and documentation overhead and the time spent on those tasks. Here, in agile development, projects emphasize simple and interactive application development. So the keywords here are simple and interactive. Then the last one is the extreme programming or XP. It is a software development framework that aims to produce higher quality software and higher quality of life for the development team. Um, the XP was founded on four core values. First is communication. Why communication? Because here in XP, there is rapid or quick building and disseminating knowledge among the members of the development team. The second core value is simplicity. Why simplicity? It's because in XP, um, simple solution is encouraged. So they start with simple solutions. And then the third core value of XP is feedback. Why feedback? Because in XP, there is direct feedback from the system. There's also a direct feedback from the customers. And there's also a direct feedback from the team. And the last core value of XP is courage. Courage. So why courage? Since in XP, the team members know when to throw the code away. They also know how to remove the source code that is already obsolete or sobrang luma na, outdated na. And no matter how much effort was used to create source code. So those are the different kinds of methodologies. Now, the last part of my report for today is what is the importance of systems analysis and design to the academe, to the society? Systems analysis and design is generally used to solve the internal problems, to improve the efficiency, and expand, opportunities, and it has a direct impact on the bottom of any kind of business, even in schools. So let's get to know some of the importance of systems analysis and design. Number one, system analysis and design benefit schools and other businesses, whether used for specific projects or across the full scope of business operations company wide. Number two, using system analysis and design helps a school or any other business identify both opportunities and problems by recognizing and evaluating strengths and weaknesses of the company. Number three, system analysis and design are crucial in situations where the integration of a multinational information system is required. Among the advantages of competing globally, especially now in the 21st century, is increased market coverage area, which is generally results in increased profits. Um, Also, number four, system analysis and design can be used to improve procedures in handling accounts receivable, in preparing and implementing a budget, and in scheduling regular or one time projects. Number five, system analysis and design also can be used to identify, develop, and market new products as well as identify the and enter new markets with existing and new products, such as in schools. What's new with the school? So this is also one of the benefits of having systems or doing the system analysis and design. And the last one is the business of business is to make money. So an obvious advantage of using system analysis and design is to improve business quality so that they can also increase their profits. So that's the end of my report. Thank you, sir. Thank you very much. Stop share. Okay.
Okay na. So, okay, very good, Sir Benedict. So, palakpakan Sir Benedict. Kahit na virtually, let's give him a round of applause. Siguro. That was a very good report. How many minutes? We have 5 more minutes. Anyway, so what I would like you to do is, especially to concentrate on the five phases of the SDLC, which are actually planning, and then the next one is more on analysis, or that is where we get the requirements, and then next will be design, implementation, and then the last one is about support. Okay, why are these important? The planning phase is where we actually have to determine whether the project is worthwhile or not. So what do we usually do in planning? First is we have to know the problem that is being solved by the project. So if we know the problem, we'll know what to solve. If we don't have the real problem, then most probably the solution will be provided is not the correct solution. So in planning, we have to know the problem, and at the same time, we have to know, we have to determine the feasibility of the project. Is it technically feasible? Is it economically feasible, or maybe is it operationally feasible? So especially economically feasible because, as we have said, one of the advantages of systems analysis design is we don't have to waste any resources, especially financial resources in maybe implementing projects. Okay, so we have to determine this before we proceed with the next one, which is actually the analysis phase. In the analysis phase, it is where we actually gather the requirements. What are the requirements? The requirements are more or less the things that users would like the system to do. We have to know what the users would like the system to do, because if we don't do this, then most probably they will not be accepting the system. If they don't accept the system, either they will not use it, or maybe they will use it, but of course it will affect their well-being. So we have to know the requirements. Once we know the requirements, then the next phase now is being the analyst and the designer. Again, two decisions: we make the software or we buy an existing package. And if we make the software, let's say assuming that we're going to make the software, then as the designer, you have to uh, create, or you have to design the end user interface, the reports, etc. And this design will now be given to the programmers, and the programmers will be developing the solution. So after the solution, then there comes this, of course, the development and the implementation. Once it is implemented, then let's say it's already running, then that it is where support, yung support. Okay, so in supporting the system, we have to, of course, still gather feedbacks from the users for further improvement of the system. And then later on, most probably after several years, then it will again start with the systems planning. That's why it's called a cycle. Maybe the system is already obsolete, then we start again with another cycle, planning, uh, analyzing, etc. So these are the phases of the systems. So as an MIS, of course, you have to know the phases. Let's say, for example, you have an employee, or maybe your IT department. Sabi ng IT department, or according to IT department, let us buy this software. Being an MIS or being an officer of your school, are you going to do that? Of course not. There should be, you should follow the phases. You should know the requirements. You should plan. You should not decide on purchasing a software yung outright na ganun, without even trying to analyze